Alright, let's sketch the function f of x is equal to x cubed minus 5x squared plus 2x plus 8 by placing it into factor form with special attention to, okay, I don't know why I wrote factor form again, but degree, number of turning points, end behavior, root intercepts, minimum, maximum points, refined sketch. Okay, so the whole works, alright? So let's take a let's convert this into factor form. So f of x here is x cubed minus 5x squared plus 2x plus 8. In order to factor this, what we want to do here, let's look at the integral zero theorem. And using the integral zero theorem, we can notice here that our potential factors can be equal to the factors of the constant 8, so 1, 2, 4, and 8, divided by the coefficient 1, plus minus 1. So our potential factors are 1, 2, 4, and 8, right? And we have to test these values. So you can do guess and check here. F of negative 1 would actually work, right? So in this case, we get negative 1 cubed minus 5 times negative 1 squared plus 2 times negative 1 plus 8. You get negative 1 minus 5 minus 2 plus 8 is 0. So according to factor theorem, then x plus 1 is a factor. Okay, so x plus 1 is a factor, and because x plus 1 is a factor, we can determine the remaining factors by employing synthetic division, right? So if we want to employ synthetic division, I'm going to put at negative 1 here. Okay, I'm going to place my coefficients out here. So this is, well, these are my terms, x cubed, x squared, x to the power 1, x to the power 0, and then I'm going to place my coefficients out here. Right, so there's going to be a 1 here, a negative 5 here, a 2 here, and an 8 here. I'm going to bring the 1 down, I'm going to multiply it. So you get negative 1 times 1, which is negative 1, then add these two, this is negative 6, negative 1 times negative 6 is positive 6, 2 plus 6 is 8, negative 1 times 8 is negative 8, and then you add this and you get 0, right? So if you add this and you get 0, basically this is like x squared term, x to the power 1, x to the power 0, that's your remainder, right? In this case, your quotient is x squared minus 6x plus 8. Okay? So because your quotient is x squared minus 6x plus 8, your completely factored form is x plus 1 times x squared minus 6x plus 8. But you can actually notice that you can factor this further. And if you wanted to factor this further, you factor this as a quadratic, two numbers that add up to negative 6, then multiply to positive 8. So you can do x squared minus 4x minus 2x plus 8. X plus 1, and you basically get x plus 1, x times x minus 4, minus 2x minus 4, and you get x plus 1 times x minus 2 times x minus 4. Okay, so that's what your expression, that's what your function looks like now. So f of x here is equal to x plus 1 times x minus 2 times x minus 4. And you can notice that if you wanted to find your roots or your x-intercepts, right, you can let f of x equal 0, and in this case what you're going to get here is your x-intercepts are going to basically be negative 1, 2, and 4. Okay. Now we also want to look at the behavior of those intercepts, specifically the multiplicity or the order, right? So if we're looking at the order, here's my particular root, here's the order, here's the behavior, and you can actually notice that all of these have an order of 1. Right, so my roots are negative 1 and 0, 2 and 0, and 4 and 0. The order is 1 consistently throughout, and it's basically going to pass through all of these points. Okay, so it's going to pass through all of these points, this guy included and this guy included. Right, just to get a much better understanding of what our sketch will look like, it will also be useful to find our y-intercept. Right, so to find our y-intercept, what we're going to do here is we're going to let x equal 0, so I'm going to do f of 0 here, which is basically if you plug in 0, you get 0 cubed minus 5 times 0 squared plus 2 times 0 plus 8, so you get f of 0 is equal to 8. So 0 and 8 is your y-intercept. And then if you wanted to sketch this collectively, I'm going to plug in my points, and you have negative 1 and 0 here. You have 2 and 0 here, and 4 and 0 here. Okay, and now what you're going to do is your y-intercept is 0 and 8, so let's place that here, right? And because we understand that our function, the leading term of our function is x cubed, the degree of our function here is basically 3. Okay, so the number of turning points you would expect is n minus 1, so the maximum number of turning points is 2. Okay, furthermore, we can understand that a here is 1, so a is greater than 0, so this is a positive odd degree function. So it's a positive odd degree function. This tells us that our n behaviors would be located in quadrants 3 and quadrants 1. So we're going to expect the n behaviors to be located here as well as here. So it should pass through this point, ends up here, right? It should loop through there, going through there. So this is a potential sketch, right? And we should expect to see, I'm just going to highlight our intercepts specifically. Okay, so these are our intercepts, and we should expect to see 2 turns, right? So there's a turn here, there's a turn here. Now because this is an odd degree function, we can only expect local maximum and minimum points, right? So there's a local maximum at 0 and 8. Okay, I'll write that here, local max at 0 and 8, and there is a local minimum, but we don't really know where the local minimum is, right? But we can understand that it's the midpoint of the 2 and the 4. So this is, let's call this an x value of the turning point. The x value of the turning point is 2 plus 4 divided by 2, which is basically 3. Okay, so to find the y value, this is basically f of 3. Okay, so let's figure out what f of 3 is. I'm just going to do it out here, but f of 3, if you plug it into the function, right, we're going to get 3 cubed minus 5 times 3 squared plus 2 times 3 plus 8. And that's going to give you negative 4. Okay, so you just plug it into this function, right? You just do f of 3 and you get that. And you can punch this out in your calculator, right? So that's what I did here. Okay, and you can get negative 4. So this point here is negative 4. So this is your local minimum. Your local minimum here should be 3 and negative 4. Okay, so now we have our local maximum minimum. Because it's an odd degree function, the domain here, x belongs to all real numbers, the range here is y belongs to all real numbers. Okay, and this is basically our refined sketch. Alright, so that's really the idea. So it's really useful to convert our polynomial function to its factor form to kind of figure out its behavior.